Hello and welcome, my friend, to the Sleepy Physicist. I'm so glad you've joined me. This space is here for you, whether you're relaxing in the dark, settling into your bed, or simply resting your eyes after a busy day. Tonight, we'll begin to explore a question that, despite its simplicity, delves into the fundamental nature of existence. Can energy exist without matter? I should offer a gentle heads up. While I'll do my best to keep everything calm and conducive to sleep, science sometimes has a way of stimulating the mind, sparking thoughts that are difficult to let go of. If this story happens to keep you up a little longer than you planned, at least you'll be a bit wiser when you finally drift off tomorrow. If you're enjoying this moment, I would be so thankful for a quiet like on this video. It helps other wary minds find their way here. And if you're feeling generous, you have the option to leave a super thanks or become a channel member, which helps keep this space softly lit for everyone who needs it. Feel free to share in the comments where you're listening from. I love seeing bedtime appear across the world like stars. Now, let's close our eyes or soften our gaze and gently enter the void. The void in virtual particles imagine nothing. And I mean true nothingness. Not just an empty room or a silent field, but no air, no dust, no light, not even a faint echo. At first, you might think of this as the ultimate stillness, a complete and final silence. But physics offers a different perspective. Even a void cannot remain perfectly empty. In the deepest nothingness, something flickers. This flicker is energy. It's not the warmth of a fire or the light of the sun, but tiny, restless sparks that appear and disappear constantly. Physicists call these virtual particles. They exist in the vacuum, borrowing their reality for only a moment before vanishing again. You could picture them as fireflies in the night, too fleeting to be held, yet too present to be ignored. Quantum mechanics and the trembling hum, you might wonder how nothing can contain something. The answer lies in the principles of quantum mechanics. At the smallest scales, the universe resists being perfectly defined. It doesn't allow for absolute certainty. A particle's position and energy can't both be precisely known at the same time. This means that even when a space is completely devoid of matter, this uncertainty leaves behind a constant trembling, a quantum vibration, a restless hum that is always there. Imagine yourself drifting in this void. Initially, the silence is all-consuming, but as your mind settles, you begin to perceive faint pulses, like ripples spreading across a vast, unseen ocean. These ripples are energy existing without any matter to anchor it. They flow through and around you, a constant reminder that even in absence, there is presence. This concept might feel strange since in our daily lives, we only experience energy through matter. We strike a match and chemical bonds release fire. Our bodies transform food into motion. We look at stars and blazing matter pulls light across the darkness. But here in the vacuum, energy reveals that it can shimmer all on its own, without a solid host. Light in the first moments of the cosmos, think about light itself. A photon has no rest mass, it's not made of matter like a stone or a living cell. Yet, it carries energy over unimaginable distances. A photon created in the core of a star might spend thousands of years bouncing around before finally escaping into open space. Once free, it can journey for billions of years, crossing the universe and carrying energy without ever gaining weight. It is a pure messenger of energy, unburdened by matter. Now, gently consider the universe's earliest moments. In the very beginning, there was no matter as we know it, only pure, blazing, unbounded energy. The cosmos was a boundless ocean of radiant energy. It was only as the universe cooled and expanded that this energy condensed into particles, forming the seeds of atoms, galaxies, stars. Matter, in a way, is just frozen energy. The solidity of your body, the stone beneath your feet, the iron in the Earth's core. All of it is energy that has been slowed down, structured, and given form. The entwined nature of matter and energy, so, when you ask if energy can exist without matter, the answer is both yes and no. Energy can live in its own forms, like light or the restless vacuum. But matter and energy are so deeply intertwined that they are constantly trading places. Matter can dissolve into energy, as when stars fuse atoms and release light, and energy can condense into matter, as when particles were born from the universe's fire. It's not so much a question of whether one can exist without the other, but rather like asking if a melody can exist without a singer. The song is distinct, but it needs a voice to be brought into the world. Sometimes, however, a faint melody can linger on its own, carried by the air, almost independent. In that same way, energy sometimes stands alone. Drifting in the void and the nature of your body now, let yourself imagine drifting further into the void. You sense the faint quantum flickers as tiny points of light. You picture photons streaming past, ancient travelers from distant galaxies. Some of them may have been traveling since long before Earth even existed. They carry no mass, yet they hold the history of the stars. Breathe deeply, knowing that your own body is made of matter that was once light. The atoms in your bones were born when energy cooled into substance. You are both solid and radiant, matter and energy in perfect balance. There is comfort in this idea. If you ever feel small or lost in the vastness of existence, remember that the same flicker in the void is also inside you. The same laws that govern the empty stretches of space hum softly in your very breath. The energy that moves stars also warms your skin. The void isn't empty after all. It sings softly and endlessly. As your mind settles deeper into this thought, notice how the line between matter and energy begins to blur. The chair you're in, the air in your lungs, the warmth in your fingers, all of it is energy flowing, shaped into temporary forms. One day those forms will change and return to other forms of energy. But nothing is ever truly lost. The flicker continues, the hum endures. Rest in that knowledge, and as you drift, another thought quietly surfaces. If energy is never still, even in emptiness, then perhaps matter is just one of its shadows, a denser echo. So, what happens when we turn our attention to that shadow and ask what matter truly is? That is where our journey will take us next. What is matter? The illusion of solidity. When you look at the world, the first thing you notice is matter's solid shapes, the weight of a stone, the feel of a floor, the curve of a cup, the presence of your own body. Matter seems to be the foundation of reality, something permanent you can touch, hold, and lean against. And yet, behind every piece of matter, energy waits like an inseparable shadow. Matter feels familiar, but what is it really? You might think of it as substance, the stuff of the universe, anything that has mass and takes up space. But if you look closer, matter dissolves into something much stranger. Atoms, the tiny building blocks of all matter, are mostly empty space. A dense core, the nucleus, sits at the center, made of protons and neutrons. Around it, electrons orbit in patterns that are less like little balls and more like clouds of probability. If you were to blow up an atom to the size of a stadium, the nucleus would be no bigger than a pea at the center, while the electrons would buzz around like whispers at the far edges. The rest is space. So the chair you're in, the floor, the entire Earth, it's all made of vast emptiness, with tiny points of concentrated energy holding the structure together. Matter feels solid, but its solidity is an illusion. The firmness of the ground or the resistance of a table comes from invisible forces. The electrical push of atoms resisting being compressed. The choreography of energy matter, then, isn't just stuff. It's a choreography of energy locked into a specific form. Take a stone in your hand. It feels heavy and still. But inside it, countless particles are in constant motion. Protons, neutrons, and electrons are humming with activity. Deep within the protons, quarks are dancing, bound by gluons, exchanging energy with every instant. The stone appears still, but it's a storm of energy on the inside. When you lift the stone even an inch, you give it potential energy, an invisible, silent energy. When you drop it, that potential energy becomes motion, a rush of kinetic energy. The stone's matter hasn't changed, but its energy shadow has. Matter and energy are woven together like this. The stone holds its shape because of the energy that binds its particles. It resists pressure because of electromagnetic energy. It falls because gravity is also a form of energy that curves the fabric of space. The solid thing you hold is, in truth, a delicate balance of shadows. The stone and the flame now. Picture a flame next to the stone. Fire glows, dances, and consumes. While the stone feels permanent, the flame feels temporary, impossible to hold. Fire is matter unraveling into energy. As wood and oxygen combine, bonds between atoms break, releasing stored energy as light and heat. The flame reminds us that matter doesn't stand alone. It is constantly interacting with energy, always ready to change and transform. The contrast is striking, the enduring stone versus the vanishing flame. But look closer, and you'll see their connection. The stone is also just energy condensed into a form. The flame is also matter releasing its hidden structure. They are both part of the same cycle, matter and energy constantly swapping roles. This exchange is not rare, it is the very rhythm of the universe. In the hearts of stars, matter is continuously becoming energy. Hydrogen fuses into helium, releasing light that travels across the cosmos. That light reaches Earth, and plants capture it, converting energy back into matter in the form of sugars and leaves. You eat the plants, or the animals that eat them, and their matter becomes part of your body. Later, your body releases heat, breath, and motion, matter returning to energy once more. Matter as a shadow of energy. Your own body is a living example of matter's shadow. You feel solid, but you are a flow. Every atom in you has been borrowed from the world around you, breathed, eaten, absorbed. The calcium in your bones was once in stars. The iron in your blood was forged in ancient stellar fires. The water in your veins has cycled through oceans, clouds, and rivers for billions of years. What you call you is matter constantly arriving, staying for a while, and then leaving again. Energy holds it together for now, shaping it into the form you see in the mirror. But the form is temporary, the flow is eternal. If matter is a shadow, then perhaps energy is the light that casts it. You can't hold energy in your hand, but you can see how it shapes matter. The warmth of sunlight softens wax. The force of a hammer strike bends metal. The quiet bonds between atoms give rise to the hardness of a diamond. Energy reveals itself only through the forms it creates, the shadows it forms. Think about literal shadows. When light hits an object, the object casts a silhouette on the ground. The shadow isn't the object itself, but its outline, a hint of its form. In a way, matter is like that, a temporary outline of energy, a form it takes to be seen, touched, and experienced. Einstein's equation and the rhythm of change. This is why physicists often refer to Einstein's famous equation, E to mc Dallao, which tells us that energy and matter are two sides of the same coin. A tiny bit of matter holds a staggering amount of energy. A pebble, if its mass could be fully converted, contains enough energy to power cities. But the universe doesn't give up this energy easily. Matter prefers to hold on to its form. Still, in specific moments, in stars, in nuclear reactions, in subtle decays, it lets go, and the shadow dissolves back into light. Now, rest in this thought. The world around you, everything you consider permanent and solid, is a delicate balance of invisible exchanges. A table isn't just wood, it's the memory of sunlight, the remains of carbon taken from the air, the quiet bonds of molecules holding hands. It's matter, yes, but only for as long as energy holds its form together. Close your eyes again and imagine the shadow fading. Imagine the stone dissolving into light. Imagine the flame cooling into ash and then scattering as atoms in the air. Matter never truly disappears, it only changes. The shadow shifts and the energy continues. And so, you might wonder, if matter is the shadow and energy is the light, what happens when you trace that shadow back to its source? What is the true connection between them? To understand more deeply, we must get closer to the smallest scales, where particles themselves flicker in and out of existence, to watch how energy holds them and then lets them go. That is where we will journey next, into the dance of particles. The dance of particles. When you listen to the stillness of the world, it's easy to believe that matter is solid, stable, and unchanging. The chair holds your weight. The walls stand firm, the ground feels eternal. But below this stillness, at the smallest scales, nothing is still. Atoms, the very building blocks of matter, are full of motion. And deeper still, within those atoms, particles flicker, join, and separate in endless patterns. The microscopic world is not ruled by solidity, but by a dance. Imagine shrinking down, smaller than dust, smaller than the atoms that make up dust. You drift through clouds of electrons, their presence more like a gentle mist than solid marbles. They move in patterns of probability, never fixed or truly at rest. You can't say with certainty where an electron is, only that it has a chance of being in a certain place. This uncertainty isn't a flaw, it's the fundamental nature of reality. At the quantum level, particles follow different rules from the large, quiet objects you touch every day. Here they don't stay still, they shimmer. Inside the atom's core, protons and neutrons are bound together in the nucleus. These aren't indivisible either, they're made of even smaller quarks held by gluons. The quarks themselves can't exist alone, always clinging together in a restless, vibrating ballet that never ends. And yet, even beyond these familiar particles, the vacuum itself is alive.